We are going to see another case study based question. The question goes as a housing society wants to commission a swimming pool for its residents. For this, they have to purchase a square piece of land and dig this to such a depth that its capacity is 250 cubic meters. Cost of land is rupees 500 per square meter. The cost of digging increases with the depth, and the cost for the whole pool is rupees 4000 into depth square. So we need to understand which topic the question is from. So let's see the question. Suppose the side of the square plot is x meters and the depth is h meters. On the basis of the above information, answer the following questions. Write the cost function in terms of h. Find the critical point. Use second derivative test to find the value of h for which the cost of constructing the pool is minimum. So from the terminology we understand this question has got something to do with application of derivatives. So let's review the data again. The land must be a square piece of land. So the capacity of the swimming pool should be 250 cubic meters. So let's make equations using that. So volume of the swimming pool is going to be, and he is asking us to take the side of the square as x and the depth as h. So my first equation will be x square into h, which is nothing but the uh, volume of the swimming pool, which is going to be 250 cubic meters. So this is given data. Then what are we given? We want to talk about the cost function. So cost is going to be the cost of the land plus cost of digging. So cost of the land is rupees 500 per square meter, but we are in need of x square meters. So cost of the land will be 500 into x square. And cost of digging, they say it is rupees 4000 h square for the whole swimming pool. So this is the cost expression. But in the first subdivision, they have specifically asked find the cost function in terms of h. That means I don't want an x square. So let me find out x square is equal to 250 divided by h. So cost function in terms of h is going to be 500 into 250 divided by h plus 4000 h square. This is the answer to the first question. The first question in the case study based question is what is the cost function in terms of h. The second part is find the critical point. So to get the critical point, we need to differentiate this cost function with respect to h. So this will give me, when we differentiate 1 by h, we get a minus 1 by h square. This is going to be 125,000 minus 1 by h square, plus I will get a 8000 h. So for critical points, we equate the for critical points we equate dc by dh to 0. So I get 125,000 divided by h square is equal to 8000 h. I can cancel 3 zeros and 3 zeros and cross multiply. We get h cube is equal to 125 divided by 8. That gives me h is equal to 5 by 2 meters. So the critical point is that this is the answer to the second question. Find the critical point. The critical point is given by h is equal to 5 by 2 meters. Then goes the third question. Use second derivative test to find the value of h for which the cost of constructing the pool is minimum. Then what is the minimum cost? So we need to find the second derivative. So let us differentiate this. D square c by dh square. Derivative of 1 by h square is minus 2 by h cube. So it is going to become 250,000 divided by h cube plus 8,000. Replace h is equal to 5 by 2. So we get 250,000 divided by h cube is 125 by 8 plus 8,000. Maybe I can cancel. This will give me 2,000 into 8. 16,000 plus 8,000, which is going to be 24,000. We know that the second derivative is positive. Therefore, our conclusion is when the depth is equal to 5 by 2 meters, the cost of making the pool. Cost of construction of the pool is minimum. Construction is minimum. They're, then they're asking what is the cost of the pool. So cost is going to be, what is the cost function given as? The cost function is given as, let me mark this as 1, let me mark this as 2, let me mark this as 3. Equation 3 will give us the cost. So cost of construction is, he's asking what is the minimum cost. So let us substitute 500 into 25. 250 is 125,000 divided by h. H is a 5 by 2 plus 4,000 into h square, which is a 25 by 4. So if I cancel 5 and 125, so I'll get 25,000 into 2. So that is going to be a 50,000 plus this is going to be a 25,000. Therefore, cost of constructing the pool is nothing but 75,000, and this is the minimum cost to construct the pool. So strictly speaking, we have answered the subdivision 1, subdivision 2, subdivision 3 is what is the minimum cost to construct the pool. We have done that. What is the alternative question? Let us do this choice question also. Use the first derivative test to find the depth of the pool so that the cost of construction is minimum. Also find the relation between x and h. We have already used to get the critical point, we have already used the first derivative test equated to 0 and got the value of h. It is going to be either you solve this question or you solve the alternative question. Alternative question is dc by dh. We have already got dc by dh. Instead of using the word critical point, they are saying by using the first derivative test, get the value of h. So dc by dh is going to be minus 125,000 divided by h square plus what is the first derivative, plus 8,000 h, plus 8,000 h. This is the first derivative, equate it to 0. You will get h cube is equal to 125 by 8, h is equal to 5 by 2 meters. In this second subdivision, what is that extra thing that they have asked is, they have first derivative test, you find the depth of the pool. So we've already got the depth of the pool, so that the cost of construction is minimum. Then they are asking what is the relation between x and h for the minimum cost. So one answer is depth of pool for cost, for cost to be minimum. For cost to be minimum is 5 by 2 meters. That is the first part. Second part is what is x. We know x square h is equal to 250 is the relation. So x square is equal to 250 divided by h, which is 250 divided by 5 by 2, which is going to be 100. That gives us x is equal to 10 meters. So the swimming pool should be having the base as 10 by 10 and the depth as 5 by 2 meters for the cost of making the pool a minimum. They are asking what is the relation between x and h. So you know that 2h is equal to 5 meters. That means 4h is equal to 10 meters, which is equal to x. Therefore, the relation between the side of the pool and the depth of the pool is, the side of the pool should be 4 times the depth of the pool, and that is what they are precisely asking us to do. They are asking, using the first derivative test, find the depth of the pool so that the cost of the construction is minimum. We found out h is equal to 5 by 2 meters, and they are asking what is the relation between x and h for the cost to be minimum. We have found out that x should be equal to 4h for the construction of the tank to be, swimming pool to be minimum.